Laboratory, we have a regulated temperature of 20 degrees Celsius, a relative humidity value of 66%, and a barometric pressure of 762.5 millimeters of mercury. Before going to the table for a compensation factor, the barometric pressure must be converted to absolute pressure. This conversion involves subtracting 2.5 millimeters or 0.1 inches of mercury for each 30 meters or 100 feet of elevation above sea level. Raleigh, North Carolina has an elevation of 350 to 400 feet. Using a value of 400 feet, an absolute pressure value of 752.5 millimeters of mercury is obtained. From the table, a compensation factor of 731.9 is found. This value is actually the last four decimal places of the air to vacuum wavelength ratio, 0.999731.9. The value is keyed into the measurement unit, then entered by pressing the VOL key. Entry of the measured specimen's temperature and coefficient of thermal expansion can similarly be entered. However, in this case, the setup will be assumed to be thermally stable at 20 degrees Celsius. Therefore, these entries will be omitted. The direction sense key allows specification of the positive and negative directions. Pressing the key causes the sign of the measurement data to toggle between plus and minus. The preset key allows selection of an initial distance or position value. In this case, an initial reading of 0 is desired, so this step will be omitted. With the optics at their minimum separation, press the reset key on the front of the console. This clears the previous measurement data. Measurement data may be automatically recorded by auxiliary equipment or manually recorded from the console's display. In this case, manual data collection is chosen. At this point, the retroreflector may be moved away from the interferometer and measurement of that displacement may begin. In this lab, various instruments and tools for length and distance measurement have been discussed and demonstrated. Each device had its own advantages and disadvantages. Successful measurement requires a knowledge of the required measurement precision, the resolution and accuracy available with various measurement devices, and the multitude of sources of measurement error. With this knowledge, the measurement device may be well matched to the measurement task, and potential measurement error may be kept to a minimum. The homework for this lab has 4 assignments. First, identify error sources, state the dimensional uncertainty associated with the fabrication of the gauge blocks, and calculate the actual length of the gauge block configuration shown in Figure A. Next, with the micrometer, measure the length of a half-inch gauge block 10 times. Calculate the mean and standard deviation. Repeat this procedure with a pair of calipers. Comment on the resolution, accuracy, and repeatability for each instrument. Suggest the factors or conditions which shaped your results. Given a displacement which varies with time as given in Figure C, choose a measurement device which will allow measurement certainty down to 10 microinches. State your assumptions regarding specimen material, thermal environment, and so forth. Qualify your choice. Given a displacement which, with the laser interferometer shown in Figure D, is measured to be 10 inches, there is no compensation for the non-standard environmental conditions. Given this environmental error and the error inherent in the equipment setup, calculate the total measurement error. The lab write-up should follow the standard format consisting of the objective, procedure, results, and conclusion. The write-ups must be typewritten or legibly handwritten. These write-ups are due at the beginning of the next lab.